Imagine a future where computing power surpasses our wildest dreams. How does quantum computing and machine learning fit into this picture? Picture a world where computations that currently take years to process could be done in the blink of an eye. This is the world that quantum computing promises. Quantum computing is not simply an upgrade of our current systems. It's a complete overhaul, a leap forward in the way we process information. Instead of bits, the binary units of data in classical computing, quantum computers use quantum bits, or qubits. These qubits can exist in multiple states at once thanks to a property called superposition, exponentially expanding the computing power. Now let's bring machine learning into the mix. Machine learning is a branch of artificial intelligence that gives computers the ability to learn from and make decisions based on data. It's the technology behind the recommendations you get on your streaming services, the voice recognition on your phone, and so much more. So what happens when we combine these two powerhouses of technology, quantum computing, and machine learning? We get quantum machine learning platforms. These platforms could potentially harness the raw, unbridled power of quantum computing to process vast amounts of data at unprecedented speeds. Imagine the possibilities. Faster, more accurate predictions, complex simulations run in seconds, solutions to problems we haven't even considered yet. The potential of quantum machine learning platforms doesn't stop there. They could revolutionize everything from drug discovery to climate modeling. They could help us unravel the mysteries of the universe, or they could simply make our everyday lives easier. However, these are not just theoretical musings. Quantum machine learning platforms are being built right now. Researchers and enterprises are working tirelessly to make this future a reality. They are exploring the intricacies of the quantum world and developing algorithms that can tap into the power of quantum computing. This is no mere fantasy. The future is here and it's quantum. Ever heard of the McGinty Equation? Sounds complex, doesn't it? Let's break it down together, shall we? The McGinty Equation, or MEQ for short, is a quantum mechanical equation that comprises several components. The first component, P's xt, is the wave function. This represents the state of a quantum system at a given point in space and time. Now let's look at PSQFT. This is the solution of the free quantum field theory. In simpler terms, it's a mathematical model that describes the behavior of quantum particles, like electrons and photons, in the absence of external influences. Moving on, we have P's fractal XTDMQQs. This represents the fractal potential term. Think of fractals as patterns that repeat at different scales. In the context of the McGinty equation, the fractal potential term describes the self-similar fractal structure of quantum systems. The parameters d, m, q, and s characterize this structure. And lastly, there's gravity xtg, which comes into play in the modified version of the McGinty equation. This term represents the perturbative effects of gravity on the quantum field. Here, g is a parameter that characterizes the strength of the gravitational force. So in essence, the McGinty equation is a mathematical model that describes quantum systems, taking into account free quantum field theory, fractal structures, and even the effects of gravity. But why does this matter? Well, this equation is a crucial tool in the development of quantum machine learning platforms. By understanding and utilizing the McGinty equation, researchers and enterprises can access and utilize quantum computing for a variety of applications. Seems less daunting now, doesn't it? The McGinty equation is just one piece of the quantum puzzle. So, we've talked about quantum computing, machine learning, and the McGinty equation. But how does it all come together? Well, it all converges beautifully in quantum machine learning platforms. These platforms are essentially the magic portals that allow us to tap into the immense power of quantum computing and machine learning. They provide a unified, accessible, and efficient environment for researchers and enterprises to harness quantum computing for various applications, from drug discovery to climate modeling. One of the key aspects of these platforms is their ability to handle complex calculations, and this is where the McGinty equation comes in. This equation may look like a cryptic puzzle, but it's really a key that unlocks the door to understanding quantum mechanics and its interplay with gravity. For quantum machine learning platforms, it's like a secret recipe that allows them to process data and learn patterns in ways that classical computers simply can't handle. The simplified McGinty equation, for instance, combines the solution of the free quantum field theory with a fractal potential term that has a self-similar structure. It's this melding of quantum and fractal properties that provides the horsepower for quantum machine learning platforms. The platforms can use this equation to run computations that would take classical computers an astronomical amount of time. But it's not just about speed. These platforms also offer a new way of thinking about and solving problems. They can understand and learn from data in a fundamentally different way, opening up new possibilities for innovation and discovery. And as they continue to evolve and improve, they're likely to become an increasingly important tool in our technological arsenal. But perhaps the most exciting thing about quantum machine learning platforms is their potential to change the game. They're not just a step forward, they're a leap into a new era of computing. They have the potential to revolutionize fields from finance to healthcare and to tackle some of the biggest challenges our world faces today. Quantum machine learning platforms are not just a technological advancement, they are a game changer. We've taken a deep dive into the quantum realm, but what does this mean for us, for our future? As we chart the course forward, the implications of quantum machine learning platforms can't be understated. These platforms are poised to revolutionize sectors from research to enterprise, offering unprecedented computational power and learning capabilities. Imagine, if you will, researchers unlocking secrets of the universe faster than ever before, or businesses predicting market trends with uncanny accuracy. That's the promise of quantum machine learning. But we're only at the dawn of this new era. As these platforms continue to evolve, we can expect even more remarkable advancements. Future iterations of these platforms will be more powerful, more efficient, and more accessible. They will push the boundaries of what's possible, challenging us to rethink our understanding of reality itself. So here's the question. The quantum leap is here. Are you ready to jump in?